So virtual networks have various design goals. They should be flexible, able to support different topologies, routing and forwarding architectures, and independent configurations. They should be manageable. In other words, they should separate the policy that a network operator is trying to specify from the mechanisms of how those policies are implemented. They should be scalable, maximizing the number of coexisting virtual networks. They should be secure by isolating the different logical networks from one another. They should be programmable, and they should be heterogeneous in the sense that they should support different technologies. So virtual networks have two components, nodes and edges. The physical nodes themselves must be virtualized. One possible way of virtualizing a node is a virtual machine. A more lightweight way of virtualizing a node is using a virtual environment, such as a vServer or a jail. The hypervisor, or whatever technology is enabling the virtual environment, can effectively slice the underlying physical hardware to provide the illusion of multiple guest nodes or multiple virtual nodes. Examples of node virtualization include virtual machine environments such as Xen or VMware, or what's called OS-level virtualization or virtual environments, such as Linux vServers. Now, in a virtual network, we need to connect these virtual machines. Each virtual machine or virtual environment has its own view of the network stack, and we may want to provide the appearance that these nodes are connected to one another over a layer 2 topology, even if they are in fact separated by multiple IP hops. One possible way of doing that is to encapsulate the Ethernet packet as it leaves the VM on the left in an IP packet. The IP packet can then be destined for the IP address of the machine on the right, and when the packet arrives at this machine, the host can decapsulate the packet and pass the original Ethernet packet to the VM or the virtual environment that's residing on that physical node. Each one of these physical hosts may in fact host multiple virtual machines or virtual environments, which creates the need for a virtual switch that resides on the physical host. This virtual switch provides the function of networking virtual machines together over a virtual layer 2 topology. The Linux bridge is an example of a software switch that can perform this type of function. Open vSwitch is another example of software that performs this type of glue function. You can see more information about Open vSwitch on the URL provided here.